In this video, we will examine the derivatives of exponential functions. In particular, we're going to focus with e as our exponential function at first. So remember, e is approximately 2.7, and we're going to look at what if we had to take a derivative of e to the x, or e to some function. If you had to take the derivative of e to the x, the rule is the derivative is e to the x. So it may seem strange, but the derivative of e to the x is e to the x. A proof of this is provided in a separate video for you to see how it's derived and how you can get this answer with all the mathematics behind it. Now, what if the exponent isn't just x? So what if the exponent is some function like x squared or 4x to the third? So that's that chain rule that comes into play now. So what if it's e to the u? Well, the derivative of e to the u is still e to the u, but you times it by u prime. So remember, that chain rule always has that you do the derivative of the outside function, they take the derivative of the inside function. And the inside function is that exponent. So the derivative of the exponent. So I usually tell my students to always remember why is the derivative of e to the u is e to the u times u prime. So always make sure you're taking the derivative of whatever is being carried along in the exponent. So let's look at some examples now of how this can be applied. So let's try these three examples. If y is equal to 3e to the x, it's just e to the x. And we know the derivative of e to the x is e to the x. Remember, 3 is a constant, so when you take a derivative with a constant in front of the function, the constant stays to be a multiple in front of that function. So y prime is still going to be 3 e to the x. So the 3 stays, and what's the derivative of e to the x? E to the x. And that's your answer. Here, question 2. Your big function is a quotient rule. So make sure you do the quotient rule first, and then when you do your u and your v, you'll see then you'll use the derivative of the exponential function e. So if your u is x, your v is e to the x, your u prime, the derivative of x, is 1. Your v prime, the derivative of e to the x, is e to the x. Quotient rule, u prime v minus u v prime all over v squared. Now, in your numerator, you have a common factor. The common factor is e to the x, so you can factor that out. When you factor out e to the x, you're left with 1 minus x all over e to the x squared, which just means one of the x's can now factor out. And so your final answer is 1 minus x all over e to the x. And that is the derivative of x over e to the x. Now, if we look at the third example, this is now the only one so far that has given you a u, or an exponent that isn't just x. So remember what the rule said. If y is equal to e to the u, the derivative is e to the u times u prime. So your u here is x to the third plus 3x. So the derivative is e to the u, so write exactly the same thing again. E x to the third plus 3x times the derivative of that exponent, which is 3x squared plus 3. And you can leave it like that. Sometimes we like to see the parentheses placed in front of e, but it really doesn't matter. So you could write it either way. But this would be another example of how you could do a logarithmic exponential derivative.